Do you want to control lights, fans, motors, and other electrical devices on a specific day and time? If your answer is yes, then this is a video to start with because this video will cover all the designing steps from logic development to circuit designing and programming.
Hi guys, my name is Fahad and welcome to Electronic Clinic. If this is your first time here and you want to learn Arduino programming, PLC ladder logic programming, SCADA application designing, SolidWorks, Visual Basic application designing and programming, from microcontrollers to send and receive data, Android, security systems, robotics, image processing and much more, start now by subscribing and clicking the bell icon so that you never miss anything.
Welcome back. Let's start building Arduino time scheduler using VB.net. The ones who don't know or have a problem with Visual Basic installation, they can watch my tutorial on Visual Basic installation, link provided in the description below. The installation tutorial is about installing Arduino IDE for C programming, Visual Basic and MGO-CV, which will be used in image processing. So guys, only watch the Visual Basic installation part, and the ones who are interested in image processing can watch MGO-CV installation as well. The components we will be needing for the Arduino time scheduler are As in the controlling circuit, the most important component is the relay, as this will be used for turning on and off the loads depending on the specific day and time as set by the owner. So we will start with the relay. This is the relay that I'll be using today in this project for controlling the loads, and the load can be AC or DC. This is the Omron LY2 24V DC DPDT relay, and DPDT stands for double pole and double throw. So this is exactly the same relay I'm going to use today. It also comes with a base socket. Which is also exactly the same as you can see in the picture. It also has the same number of contacts, 4 on one side and 4 on the other side. So there we have 4 contacts, and over here as well. So, but it doesn't matter if you don't have the base socket. You can make your own PCB for this relay. If you don't know how to make a PCB, watch my tutorials on PCB designing. It will really help you. Or you can directly solder wires with its contacts. But I recommend you should use the base socket because it saves a lot of time. You can directly connect wires. And another advantage is if in case the relay damages in the future, you can easily replace this with another one. Simply unplug the relay, get a new one and plug it again, and that's it. So before we start the design calculations and wiring, let's first go through the concepts of how a relay works. A relay is basically a switch, but not like a switch that's on a wall. No way. A wall switch relies on someone to flip it, which will then control a light or some other type of load. A relay is switched by electrical power and not a human. This is done by energizing a coil. The relay changes state just like a wall switch would. Therefore, when you energize a relay, you are switching circuits off and on. Relays have many purposes and are used in a variety of ways, such as electronic circuit boards, machines, appliances, automobiles, and the list can go on. And if you watch my previous tutorials, I have been using relays for controlling AC bulb, DC gear motor, solenoid valves, etc, etc, etc. So the main purpose of relay is to switch electrical circuits off and on at given times and allow circuits to be automated. A great advantage with relay is the ability to switch many different circuits of different voltage types all at once by using the same relay. Now let's start the design calculations. Here is the relay. So we can start with the driver circuit designing. First we should know about the relay contacts, like which are the coil contacts: common, normally closed, and normally open. As in the designing we will be needing the coil resistance, so let's first find out the coil contacts as per the schematic given on the top of the relay. This is a schematic. As you can see, it's not quite clear, but you will have an idea. So this is schematic on the top of relay. So these two are the coil contacts, these two, this one and this one. These two are the coil contacts. So let's confirm this using digital multimeter. So turn on the GMM. Okay, now it's working. Okay, now set it on 2K resistance and let's confirm these two. So as you can see, the resistance is 0.624 K, 0.625 K. So the resistance is 0.625 K, which is equal to 625 ohm. And as we know that this is a 24 volt relay, so using the formula V is equal to IR, we can find out the current. V by R is equal to 24 by 625. And let's use this calculator. 24 divided by 625, which is equal to 0.038, and which is equal to I equal to 38.4 milliamps. So this means that we need 38.4 milliamps to energize this relay. So we will need a transistor that can handle currents more than 38.4 milliamperes. So for this we have a transistor which is 2N222, which is an NPN transistor. So we will use this. So now as per the circuit diagram on top of the relay, the pin number 1 is normally closed, pin number 2 is also normally closed, pin number 3 is normally open, and pin number 4 is also normally open. Pin number 5 and pin number 6 are the common pins, and 7, 8, 8 are the coil pins. So this is the circuit diagram. One side of the relay coil is connected with plus 24 volt DC, and it doesn't matter whether you connect 24 volt DC on this side or on this side. So just connect 24 volt DC to one contact of the relay coil, and the other side is connected with the transistor collector, and the emitter is connected with the ground, and the base is connected with a 10K resistor, and this side can be connected to a microcontroller. It can be Arduino Uno or 8051 family controller or a PIC microcontroller, and just use 5 volts to turn on this transistor, and then this transistor can turn on this relay. So with the help of using this type of relay, we can use two different types of voltages. For example, we can connect for example AC loads on this side and a DC load on this side, or for example we can connect a 220 volt AC load on this side or 110 load on this side. So it can control two different types of loads with two different types of voltages, or we can also use the same voltages on this side and this side. So now we will build this circuit on a Vero board. So let's start the soldering. Okay, this is 2N222 NPN transistor, and this is 10K resistor. If you check the pinouts of the 2N222 NPN transistor, you will find that the leftmost pin is the emitter, and the middle one is the base, and the rightmost pin is the collector. Okay, so now let's start the soldering. Let's connect these two wires. And apply some solder. And now connect this with the transistor emitter. Okay, now we will connect this wire with the Arduino ground and this one with the 24-volt supply ground. And now let's connect another wire with the collector. Okay, now let's connect another wire with a 10K resistor. Okay, now all the wires are connected. These two wires are connected with the transistor emitter. This wire will be connected with the ground of the Arduino, and this wire will be connected with the plus 24-volt supply ground. And this wire, which is connected with the collector of the 2N222 transistor, this will be connected with the relay coil. The wire which is connected to the 10K resistor, this will be connected to a microcontroller. So with the help of this wire, we can give 5 volts to the NPN transistor, and we can turn it on and turn it off. Okay, so here is the way I just plugged it in. You can just plug it in, and these two are the coil pins. So let's connect the wires. As per the schematic, as I told you, that one side will be connected with the plus 24 volts. Okay, so this wire will be connected with the plus 24 volts of the supply. And now let's connect the collector wire. Okay, so now the wiring is completed, plus 24 volt, and the other side is connected with the collector of the 2N2 transistor. These are the ground wires, and this will be connected with the Arduino.
So now let's start the programming, and while the Arduino IDE is open, first of all let's define some pin integer relay equal to 13. Load will be connected with this relay. Okay, and white setup and white loop. As every Arduino and Mega needs at least two functions, which are the white setup and white loop. The white indicates that this function is not returning any value, and as the parentheses are empty, so it means that this function is not taking any arguments as inputs, and similarly for this one. So as we will doing communication with the computer through VB.NET, so for that we will have to activate the serial communication. So serial dot begin, and 9600 is the baud rate. Now pin mode relay is this will be used for controlling the load, which is an output device. So we will write output, and let's keep the load off. Digital write relay low. Okay, now so if serial dot available greater than 0, so it means if serial dot available greater than 0, this means that check if there's data coming from the Visual Basic application. If there's data available on serial port, so what to do? Let's define another variable which is of the type character data, and so data equal to serial dot read. Okay, and if data equals for example 1, we will use 1 for turning on the load. Then what to do? Digital write relay high. And just simply copy this code and paste. And if it's 2, and let's use 2 for turning off the load. So if data equals 2, single quotes means that it's a character, and simply write low. And let's compile, let's check for the errors. So as you can see, there are no errors, and so our program is ready. And now we will start the Visual Basic application designing, and after that we will upload the program and practically check the project in action. So I'll be back. Now it's time to start the Visual Basic application designing. Open the Microsoft Visual Basic 2010 Express, and we will consider that we are making this time scheduler program for a hotel room. So click on a new project and make sure the Windows Form application is selected, and over here you can write any name like time scheduler. Okay. Let's start with displaying the current date and time. For that we'll be needing text box. So make one over here and another one. Let's use this for the date, and we need labels. One over here and another one. Let's name this as date, and this one is time, and let's change its name to txt date, and this one txt time. Okay, let's do some settings. Okay, and we need another label, and let's write over here current date and time. Sorry, that's the name. We can't, we are not supposed to change the name. We have to change the text, which is right over here. Current date and time. Let's also change the name of the form and keep it Arduino time scheduler. Okay, and now we'll need 5 more text boxes for entering the month, day, year, and minutes and hours. So for that we will also be using the text boxes. So let's start from here, and this will be used for the month. So let's change it txt month, and just copy and paste, and this one will be used for txt day, and again paste, and this one will be used for txt year. Okay, and now again paste and paste. So this one will be used for minutes, and this one for the hours. So txt minutes and txt hours. We will be entering time, hours in 24-hour formats. And now we need some labels, so let's add one over here, and text, change it to month. And copy and paste. We'll make this one day. Again paste, and this one here. And now for the minutes and hours, so paste and paste. So minutes and hours. Okay, now we'll be needing a toggle button for turning on and off the load. So for that we'll be using a text box. So let's add this one and change its name to load one. Okay, but as you can see, this is a text box. When we run this program, you see it's not a button, actually it's a text box. As you can see, it's not a button. So let's convert that into a button, and that's really easy. Just go to appearance while the text box is selected. First let's change its name. Let's make it a CMD load. Okay, and now while the text box is selected, just go to the appearance. Now here it's normal, and change this to button, and now you can see this is button.
and also click on the auto size and make it false. So now you can control this, like you can change its size. So this is okay, and now let's change the font. Let's make it 12 and bold, and that's load 1. So if we play this, as you can see, you can see it's a button. It's not doing anything as there's no programming. Okay, so this is one, and we will need one other button for starting. So let's name it CMD start, and let's change the text from load 1 to start. Okay, so that's it for now. I will start the programming and we'll see if we need something else. Okay, so let's save this. We will be doing a serial communication with the Arduino. So for this we'll be needing a serial port. So double click over here, and as you can see over here, it's added serial port number 1. We will also be needing a timer. This timer 1 will be used to update date and time every 1 second. So select timer 1 and enter another 0. So this is 1000. This is in milliseconds. So 1000 milliseconds equal to 1 minute. And we will also be needing one more timer, and let's also keep this 1000, which is equal to 1 second. So this timer 2 will be used with a start, and timer 1 will be used for updating the date and time. And this is the serial port 1. So now let's start with the port settings. Double click on the form. So form 1 load. So let's start with the timer 1 activation. So timer 1 dot enabled equal to true. And now let's do the COM port settings. So serial port 1 dot close, and serial port 1 we will need port name. So port name equal to COM5. In my computer the Arduino is installed on COM5. If it's installed on COM4 on your computer, or COM6, COM7, so you can change that. So enter that number over here, and now we need to define the baud rate. So that is the serial port 1 dot baud rate, which is equal to 9600, which is the same baud rate which we used in the Arduino programming. And now we will have to define the data bits. So serial port 1 dot data bits equals to 8, and then the parity you have to use none. So serial port 1 dot parity equals to parity dot none. And another one, serial port 1 dot handshake equals to handshake dot none. We also don't need this, and so that's why it's none. And serial port 1 dot encoding equals to system dot text dot encoding
dot default. Okay, actually I missed this line, so I added serial port 1 dot stop bits equal to stop bits dot 1. And now let's go to the top and write imports system dot io and imports system.io dot ports. Okay, now after this we will start coding for the timer 1. So now let's double click on the timer 1. So txt date dot text equals to date dot today, and txt time dot text equals to time of day. Now let's run the application and check if it can display date and time. Okay, now 4/17/2018 and 6:42. So it has access to the system current time. Okay. Now again click on the form, and this time we do coding for this, so double click and let's start with the programming. So if cmd load dot checked is equal to true, then what we have to do, we have to send serial port 1 dot open. First of all we have to open the serial port, and then serial port 1 dot write 1, as 1 will be used to turn on the load, so 1 will be used to turn on the load. We don't need a semicolon, that's not a C programming. And then serial port 1 dot close, and else serial port 1 dot open serial port 1 dot write 2, and serial port 1 dot close. So what does it mean? This instruction means that check if the button is pressed, and we are talking about this button. So check if this button is pressed, then first of all open the port and send 1 to the Arduino, and then close the port. Else, if we turn off the button, then open the port and send 2, and then again close the port. Okay, so far we did the coding for this and for the timer 1, and now let's do coding for this one. Okay. Double click the start and let's activate the timer 2. So if cmd start dot checked is equal to true, then timer 2 dot enabled is equal to true, else timer 2 dot enabled is equal to false. Okay, so before we enter into the timer 2, before we start coding over here, let's first define 2 variables over here, and those are for the day and month. So dim day equals to today dot day, and dim month equals to today dot month. Okay, so now let's start the programming here. And over here we will be needing some variables. So dim day 1 as integer. So this day 1 is actually just a variable. You can set any name. And dim month 1 as integer, dim minutes as integer, and dim hours 1 as integer. And now day 1 equals to integer dot parse txt day dot text. Now I will tell you what does it mean, but first let's complete the coding. And month 1 equals to integer dot parse txt month dot text, and then minutes 1 equal to integer dot parse txt minutes dot text, txt minutes dot text, and hours 1 equals to integer dot parse txt hours dot text minutes. So yeah, the one is missing, minutes 1. Okay, now if day equals to day 1 and month equals to month 1 and minutes 1 equals to minute now, and hours 1 equals to hour now, then what to do? Then cmd load dot checked equal to false. So it will turn off the load. So if day is equal to day 1 and month equals month 1 and minutes 1 equal to minute now, so let's add another one, and we'll need it and if okay
So over here, as you can see, that day1 is equal to integer dot bus txt day dot text. Actually, it's reading that value from the text box and then convert that into integer and store that value in day1. So similarly for these one. Okay, so now the programming is completed. Timer 2 is done. CMD start. Load checked. Timer 1. So now the programming is completed, and let's check this. So now, as you can see, the Arduino is connected and it's on COM5, so that's why we used 5 in the programming. Now let's upload the program. As you can see, this is on. And sorry, I'm connecting the SPAT relay because this is nighttime over here, and right now there is no voltage coming from the solar panel. I have already made a tutorial on DP/DT relay, so you can watch that. So we will check this SPAT relay, and now the program is uploaded, and now let's open the program. Let's run this. Okay, now it's April 4th and today is 17, and right now on my system the minutes are 33, so I will enter 34. Okay, 34, and the hour is 17:07, so I will enter 19, and when I click on the load one, as you can see, it has turned on the load one, and now I will click start. So now the load will remain on for this much time. Okay, when the time is completed. So currently I've given 34 minutes. So and currently the system time is 33. So when the system time will become 34, it will automatically turn off. So we can take it as an example. If there's a hotel room and you take that room for 1 hour or 1 day, over here you can set the time, the day, the month, the day, the minutes and hours. And now you can see it's automatically turned off. Why? Because the time is completed. So now if I give it, for example, 30, it's now 34, and now I give it 35. Okay, and I turn on. So as you can see, now the relay is on, and now when the system time will be 35, it will automatically off. So in the VB.NET in the programming section, I use the AND instruction. So when this is true and this value is true and this value is true and this value, when all the 4 values are true, then the load will be turned off. Otherwise it will never turn off the load. So currently the minutes are 34 in my laptop, and now you can see it's now 35. And now over here you can also see the time, the current time and date. So from here you can have an idea. So for example, now let me change it to 18 to tomorrow's date, and now let me click this one. So as you can see, the minutes are equal to 35. Why it's not turning off the load? Because now the days changed. So if I change it back to 17, it will automatically off, as you can see. So if I keep it at 18, it will remain on, and when I change it to the current date, as you can see, when I enter the value, you can see, so it can be controlled. So as you can see, it cannot be turned on. Why? Because the time is completed. So that's it. If you like my video, subscribe to my channel, like and share my videos with your friends, and thanks for watching.